today we're going to see a non-operational amplifier and how we derive the equations for it and what it does. On the screen you have one such operational amplifier that we're going to call it a non-inverting operational amplifier. So it's connected a little different than the other example we saw, but it's important that we see how the equations work out and how it actually works. So I'm going to go from here and we say, okay, in here you have that the output voltage in here is let's see, yeah, here the output voltage is the operational amplifier constant, you know, this amplification in here, multiplied by the difference in voltage V sub 1 and V sub I. So V sub I minus V1 multiplied by A is the output voltage. So and here we can say because of the way it's connected, you may say using voltage division, you have that the voltage 1 of S, voltage 1 of S is equal to Z1 of S divided by Z1 of S plus Z2. Okay, and this multiplies by the voltage output of S, like this. So from here, you know, this is the way we're doing it in here is because you see, you say, why don't we put it here? Because you have that I1, which is over here, and then you have I2, which is over here. We look at this node right there, you know, this one right here. You have that I1 plus I sub 2 is equal to I sub 3, right? So if this is the case, we know that V sub 1 times Z sub 1 plus V sub 1 times Z sub 2 is equal to V sub output times Z1. So in here you have that this is how we obtain this. So you could write it as I wrote it over there. So you could say that Z1 times V sub 1, okay, plus Z sub 2 times I sub 2 should be equal to Z sub 2 times V sub out. So if this is true, then it follows what I was trying to say. This is V sub 1 times Z sub 1 plus b sub 1 times z sub 2. Excuse me, here's a little problem. There we go. Z sub 2 plus b sub 1. So if you have it like this, you know that b sub 1 times z sub 1 plus z sub 2 is equal to z sub 2 times b sub 2. Therefore, you can write that b sub 1 is equal to b sub 0 hold on for a second, this I sub 3 this is b sub 1 is equal to z sub 2 z sub 2 times b sub 0 over z sub 1 plus z sub 2. Alright, so if you write it down, and here we continue, let's say that b sub 0 is equal to, from here, a times b sub let's multiply like this, b sub I of s minus, this would be see, I don't want to make a mistake in here. I have one too many parentheses, this one. Yeah, there you go. And then we have in here, this is a times z1 over z1 plus z sub 2. Okay, and all this multiplied by b0, b output of s. Okay, so in here, if we keep developing this equation to obtain the b output over b sub I, this is what we want. Isn't it true that we could this is what we want? If we have of this b sub 0, you have b sub 0 multiplied by 1 plus a times z1 over z1 plus z2, and then this is equal to a times b sub I of s, like this. So it follows that if you establish b out over b sub I like this, then you would have something like a divided by 1 plus a times z sub 1 over z sub 1 plus z sub 2, like that. Okay, if you multiply both sides by 1 over a times, of course, a, and then you come down here and you multiply 1 over a times 1 plus a z sub 1 over z sub 1 plus z sub 2, like that. What do you get with this? You get a very interesting result, because you have this transfer function of the voltage output in relationship to the input in here, that is like 1 divided by 1 over a plus z sub 1 over z sub 1 plus z sub 2. Yeah, and then you could say if a is big, infinity, what would happen? If a is big, you have that b sub 0 of s over b sub I of s, like this. Okay, is going to be equal to what? See, this term would go to 0, right? This would be like 1 over z sub 1, and then over z1 plus z sub 2. So isn't it true that now from here the b sub output in relationship to the input is going to be z1 plus z2 over z sub 1. You see, no change in sign occurred. So this is the transfer function of this operational amplifier that relates this voltage in here, relates this voltage on this side over here. I don't know why it moves, but okay, this one to this voltage. That's what we have established here. So this is the equation. Obviously you can see there's no change in the signal. This is non-inverting op-amp. People refer them as op-amps also, for short, for operational amplifier. So I think we need to practice some more on this, and I would like to show you a different example if we can, so that we practice this obtaining the transfer function of the output of the operational amplifier to the input of the operational amplifier. But for the purposes of this operational amplifier that you're seeing here, of this one in here, for purposes of that, this is the transfer function. This is the transfer function right there.